Yes. So we are doing chemical properties of alcohols, second category. And this category was reactions involving bond cleavage between carbon and oxygen. Now we are coming to the last property under this category. This is sixth property, that is dehydration. Dehydration means removal of water. Dehydration. That is alcohols containing minimum one beta hydrogen atom, containing minimum one beta hydrogen atom, lose a molecule of water, lose a molecule of water when heated with concentrated sulfuric acid at 160 to 170 degrees centigrade, or with phosphoric acid at 100 to 110 degrees centigrade, or alumina. Alumina is Al2O3. Alumina at 622 to 633 Kelvin. 622 to 633 Kelvin to give an alkene according to Sazov rule. According to Sazov rule. You know Sazov rule very well. Leads to formation of more symmetrical or more alkylated alkene. For example, this is 2-butanol. You can see there are two beta carbon atoms on either side. Hydrogen can go from one of the two sides, but hydrogen will be eliminated from this beta carbon atom, which will lead to the formation of more symmetrical alkene, that is 2-butene. I'm giving you time. Please note down all the reaction conditions above the arrow. Yes, hope you've done. Further write down, since reactivity of alcohols, increases in the order primary less than secondary less than tertiary, it means tertiary has maximum reactivity. So increases in the order so and so, comma, reaction conditions become milder with increase in reactivity. It means as the reactivity increases, reaction conditions, that is temperature, etc., they become milder and the reaction will take place. I'm giving you examples for primary, secondary, and tertiary alcohols. Right now, for example, this is ethanol, primary alcohol. We need concentrated sulfuric acid at 160 to 170 degrees centigrade. Product is ethene plus water. Second, 2-propanol. 2-propanol is a secondary alcohol, and the reactivity of secondary alcohol is more than the reactivity of primary alcohol. It means In this case, reaction condition will be slightly milder, although not much change. This will take place at 440 Kelvin. 170 degrees centigrade is 443. This will take place at 440 Kelvin. Not much of difference. Third example. Now tertiary. Reactivity of tertiary is maximum. In this case, reaction temperature will be pretty low, and in place of concentrated sulfuric acid, reaction can take place even with even by using 20% sulfuric acid. 20% sulfuric acid at 358 Kelvin. In case of secondary, add one thing. This concentrated sulfuric acid is comparatively dilute. As we use in case of primary alcohol, compared to that, it is a little dilute. This we can use 85% sulfuric acid. 85% sulfuric acid can be used. Now, in your syllabus, you have the mechanism of dehydration. Now, write on next heading, mechanism of dehydration. Mechanism of dehydration. Write on step 1. Step 1. Protonation of alcohol. Protonation of alcohol. That is, sulfuric acid ionizes to give H plus ions which protonate alcohol to give an oxonium ion. To give an oxonium ion. Write down equations. Sulfuric acid gives H plus and HSO4 minus hydrogen sulfate ion. Let us say I take the example of 2-butanol. Oxygen, you can see, has 2 lone pairs of electrons. This H plus ion will be used in protonation, means will combine with oxygen of alcoholic group. One lone pair of electrons of oxygen will be used to form a bond with H plus ion. This is protonation. You can see oxygen, after giving lone pair, carries positive charge and is left with only one lone pair of electrons. Step 2. Formation of carbonium ion. Formation of carbonium ion. Oxonium ion loses a molecule of water to form a carbonium ion. To form a carbonium ion. Write the equation. The way I have drawn this arrow, that is very important. This represents heterolytic cleavage. Electrons of the bond between carbon and oxygen, they go with oxygen atom, right? So this will leave a positive charge with carbon. That is, a carbonium ion is formed. And neutral water molecule is eliminated. You can see oxygen now carries 2 lone pairs of electrons. Next, step 3. This is the last step. Step 3. Elimination of proton H plus. Beta elimination of H plus ion from carbonium ion gives an alkene according to Sazov rule. According to Sazov rule. Equation. In the first step, HSO4 minus ion was formed. Hydrogen from beta carbon atom will be eliminated as H plus ion. And according to Sazov rule, this beta hydrogen will be eliminated from the left carbon, that is this one. This combines with HSO4 minus to give sulfuric acid. These electrons of this bond will be utilized to form a pi bond between alpha and beta carbon atom. So product is 2-butene and sulfuric acid is regenerated. Remember, this sulfuric acid cannot be reused because this gets diluted. How does it get diluted? Water is eliminated, and that water which is eliminated will dilute sulfuric acid when it is regenerated. So these were chemical properties of alcohols. Next topic. Chemical properties of phenols. Chemical properties of phenols. If you remember, we have already done resonating structures of phenol in alkyl and aryl halides. On that basis, I'm dictating you one sentence and then we'll proceed with reactions. That due to resonance, electron density in phenol is high at ortho and para positions. That is why phenols undergo ESRs, electrophilic substitution reactions, at these positions. Electrophilic substitution reactions at these positions. Now we'll take up these properties one by one. Right, number 1, nitration. First property, nitration. Right, phenol reacts with concentrated nitric acid as well as with nitrating mixture to give picric acid, PICRIC, picric acid. Write down equations. Phenol plus THNO3. 3 molecules of concentrated nitric acid. For sulfuric acid, I have written may or may not. We may use sulfuric acid, we may not use sulfuric acid. In both cases, product obtained will be same, that is picric acid. Picric acid plus 3 molecules of water. IUPAC name is very easy, 2,4,6 trinitrophenol. 2,4,6 trinitrophenol is IUPAC name. Common name is picric acid. I hope you know concentrated sulfuric acid is an oxidizing agent. Now, due to that, what will happen? Right on. In this reaction, yield of picric acid is low due to the oxidation of aromatic ring of phenol molecules in the presence of nitric acid. Now, if we want a better yield of the product, then what we have to do? In that case, first we react phenol with sulfuric acid. That is, sulfonation will take place. After sulfonation, we use nitric acid. We get the same product, that is picric acid, but this time yield will be better. Next paragraph. Sulfonation of phenol with fuming sulfuric acid. Fuming sulfuric acid is nothing but concentrated sulfuric acid which is saturated with SO3 gas, right? That is called fuming sulfuric acid. I'll repeat, sulfonation of phenol with fuming sulfuric acid followed by reaction with concentrated HNO3 gives picric acid in higher yield. That are two equations. Phenol with 2 molecules of concentrated sulfuric acid in the presence of SO3 gas. This is fuming sulfuric acid. This gives sulfonic groups will be introduced at 2 positions, one at ortho, one at para. Name of this product is phenol 2,4-disulfonic acid. I'll repeat, name of this product is phenol 2,4-disulfonic acid. Now, this product is reacted with concentrated nitric acid and we get picric acid. That is second equation. Three molecules of concentrated nitric acid gives picric acid. 2 molecules of sulfuric acid will be regenerated. Right? So whether we use only concentrated nitric acid, or we use nitrating mixture, or we first sulfonate and then nitrate, in all the three cases, product obtained is a trinitro product. But if we want to prepare a mononitro product, then reaction conditions have to be mild. Right on next paragraph. For mononitration, phenol is reacted with dilute HNO3 at low temperature. At low temperature. Write the equation. Phenol with dilute HNO3, temperature should be 10 to 15 degrees centigrade maximum, or can be even below this. This will lead to the formation of a mixture of ortho and para nitrophenols. This equation is not balanced and should not be balanced, right? You should leave it like this only. Now, there's a very important question which comes in board exam, that if we have a mixture of ortho and para nitrophenols, how do we separate these two compounds, and what is the basic principle behind that method used for separation? Right on, next paragraph. Mixture of ortho and para nitrophenols is separated by steam distillation, because orthonitrophenol is more volatile. More volatile means changes into vapors more easily, more volatile, and has lower boiling point due to intramolecular hydrogen bonding, whereas paranitrophenol is less volatile and has higher boiling point due to intermolecular hydrogen bonding, as shown below. So whenever you answer this question, you'll have to draw inter and intramolecular hydrogen bonding. Draw these. Think of polarity of bonds in terms of difference in electronegativity. OH bond is polar with hydrogen carrying partial positive charge. Nitrogen oxygen bond is polar with oxygen carrying partial negative charge. This dotted line represents hydrogen bonding within the molecule. That is why this is called intramolecular hydrogen bonding. Intramolecular hydrogen bonding. This is the case of orthonitrophenol. Now coming to para. Again, the same principle. Oxygen carries partial negative charge. Hydrogen carries partial positive charge due to polarity of bonds. This is the polarity and this is the polarity of bonds. This is hydrogen bonding between two different molecules, therefore called intermolecular hydrogen bonding. Intermolecular hydrogen bonding. Second property, bromination. Bromination. Phenol reacts with bromine water to give white precipitates of 2,4,6 tribromophenol and bromine water gets decolorized. Bromine water gets decolorized. This reaction can be used as a distinguishing test for phenols and is called bromine water test. And is called bromine water test. So remember, bromine water test can be used to test for the presence of unsaturation. Unsaturation is multiple bond between carbon atoms in the open chain. Same bromine water test can be used for the distinguishing purpose of phenol, right? Write the equation. Phenol with 3Br2. Water is just acting as solvent, nothing else. Product is 2,4,6 tribromophenol, and this is in the form of white precipitates. Bromine water, which is brown in color, gets decolorized. Now, you know, water has a very high polarity. Now, in this reaction, if you want monobromination, that is, if you want to introduce only one bromine at a time, then we'll have to use a solvent whose polarity is low and reaction temperature should also be very low. Right on, next paragraph. For monobromination, reaction has to be carried out in the presence of a non-polar solvent like carbon disulfide CS2, carbon disulfide, or CCl4, carbon tetrachloride, at 0 degrees centigrade. At 0 degree centigrade. Write the equation. Phenol with bromine. Now we'll have to change the solvent. We'll have to use non-polar solvent, CS2 or carbon tetrachloride. In both the cases, dipole moment is 0. Gives a mixture of ortho and para bromophenols. Ortho and para bromophenols. Next property. Third property, KOLBE. L is silent. Cobb's synthesis or Cobb's reaction. Cobb's synthesis oblique Cobb's reaction. That on phenol reacts with carbon dioxide CO2 and aqueous NaOH at 400 Kelvin and 4 to 7 atm pressure to give sodium salicylate, SALICYLATE. Sodium salicylate means sodium salt of salicylic acid. To give sodium salicylate, which on acidic hydrolysis gives salicylic acid. Now write down equations. Phenol, carbon dioxide, aqueous NaOH, 400 Kelvin, 4 to 7 atm pressure. Now look here. Just try to understand. If you remember, when I taught you about acidic nature of alcohols and phenols, there I told you that phenol reacts with aqueous NaOH to form salt and water. Imagine we are not using carbon dioxide. Phenol and aqueous NaOH will react to form sodium phenoxide and water. This is ONA, that is sodium phenoxide. And the second product is water, which I'm writing below the arrow. Minus water means water is one of the products. Right? Now, hydrogen from alpha carbon atom means ortho position, and CO2, they combine together to form COOH group. COOH. This product will undergo proton transfer. This is unstable. First of all, unstable molecule or compound is written within square brackets. First of all, enclosed in a square bracket. Square bracket means this is unstable. This will automatically undergo a change. Now, what is the change it will undergo? It will undergo proton transfer. Proton is H plus. It means H plus transfer. Proton, that is H plus transfer. Now, what is this H plus transfer? What is proton transfer? See, this is COH group, which is acidic in nature. Originally, this group is OH, which has changed into ONA. If we compare phenolic group, that is OH, and COH, COH group is more acidic than phenolic group. I'll repeat, COH group is more acidic than phenolic group. Due to this, salt of more acidic group, that is salt of COH group, should be preferentially formed. That is why H plus and Na plus, they will exchange their positions. This will become OH and this group will become COONA. This is proton transfer. You can skip this unstable intermediate and directly write this as the product. This is sodium salicylate, sodium salt of salicylic acid. Now, acidic hydrolysis of this salt will give salicylic acid. You already know name of this compound, salicylic acid, which I told you in nomenclature. Next property. REIMER, Rimmer-Timon reaction. REIMER, TIEMANN, Rimmer-Timon reaction. Now, this reaction has two parts. Write down A part. A part. Phenol reacts with chloroform and aqueous NaOH at 340 Kelvin to give sodium salt of salicylaldehyde, SALICYL aldehyde, salicylaldehyde, which on acidic hydrolysis gives salicylaldehyde. Now write down equations. Phenol, chloroform, aqueous NaOH, 340 Kelvin. Again, phenol and NaOH will react to form salt and water, ONA, and water I'm writing below the arrow as minus water. Now I'll use chloroform. I've written chloroform as Cl CHCl2. hydrogen from orthocarbon and chlorine of chloroform will be eliminated as HCl minus HCl. This hydrogen will be replaced by CHCl2. I hope you remember the meaning of this bracket, parenthesis, unstable. Reaction flask in which this product is formed, that reaction flask contains aqueous NaOH. Aqueous NaOH will replace these two chlorine atoms. What is that? NSR, nucleophilic substitution reaction. Both chlorine atoms will be replaced by OH groups, which will be again unstable, will lose water, and will give a CHO group. So I'm writing everything. So this is with aqueous NaOH, ONA, CH with two OH groups. Unstable, loses water. After loss of water, it becomes CHO. This is sodium salt of salicylaldehyde. In fill in the blanks or in the exam, you can skip both the intermediates and you can directly write this product. Acidic hydrolysis of this product will give salicylaldehyde. Salicylaldehyde. Now B part. B and A part are very much similar. Read on. In place of chloroform, if CCl4 carbon tetrachloride is used, product obtained is salicylic acid. Product obtained is salicylic acid. Now write down all the steps. There'll be slight difference. I'll keep on making changes, or I can rewrite, doesn't matter. This is CCl4, NaOH aqueous, 340 Kelvin. Again, OH group will change into ONA group, salt. And the other product is water, which I can write below the arrow. One chlorine from CCl4 and hydrogen from orthocarbon will be eliminated as HCl. Hydrogen is replaced by CCl3. Next, same step as we used in A part, will react with aqueous NaOH, NSR will take place. One stable with aqueous NaOH. All three chlorine atoms will be replaced by three OH groups. Naturally, unstable, will lose water. COH group. Even this product is unstable. Do you remember? This will undergo proton transfer. H plus transfer. It means you can skip all intermediates and directly write this product, right? In fill in the blanks, you can directly write this sodium salicylate. Acidic hydrolysis will give salicylic acid. Acidic hydrolysis gives salicylic acid. Next property. Now we have, although we have 4 more properties, but they are all very small properties. We'll finish in maximum 7 to 8 minutes. Next, reaction with zinc dust. Zinc dust means zinc powder. And when phenols are heated with zinc powder, they lose oxygen atom of OH group. This is called reduction of phenols. Removal of oxygen is reduction. This is called reduction of phenols. This reaction is for phenolic group only. For phenolic group only. For example, zinc will remove oxygen and form zinc oxide. And the organic product formed is benzene. Write down one more equation. On the benzene ring, there is one OH group and one CH2 OH group. One group is alcoholic, the other is phenolic. This reaction is only for the phenolic group, not for alcoholic group. It means product is benzyl alcohol. Right? This OH group will not be removed because this is not phenolic group. Next property. Oxidation. Oxidation. Phenol undergoes oxidation with chromic acid to give a conjugated alternate single double conjugated diketone called benzoquinone. Write the equation. Phenol with Na2Cr2O7 sulfuric acid. This mixture of sodium dichromate and sulfuric acid is called chromic acid mixture. This is benzoquinone. If you see carefully, this is a conjugated compound. It has alternate single and double bonds. Look here, double bond, single, double, single, double, single, double, single. Right? So this is a conjugated diketone. Next property, Williamson's synthesis. You came across Williamson's synthesis in alkyl halides also. Right on. Sodium salt of a phenol reacts with an alkyl halide to give an aliphatic aromatic ether. To give an aliphatic aromatic ether. Like the equation. This sodium salt of phenol reacts with alkyl halide. You can see byproduct is NaX, gives this is aliphatic aromatic ether. I think nothing new for you. This is Williamson's synthesis. Last property. Reaction with FeCl3, ferric chloride. Reaction with ferric chloride. Phenol reacts with FeCl3 to give a violet complex. To give a violet complex. Reaction can be used as a distinguishing test for phenols. That's the equation. Three molecules of phenol plus FeCl3 gives FeOC6H5 thrice plus 3HCl. 3 hydrogen from here and 3 chlorine atoms. This product is violet in color. So with this, we finish chemical properties of phenols. And next time we'll be starting with ethers. Right? Chale, you can log out now.